Hi everyone. So today we're going to learn about what is called synthetic division. It is kind of like trying to make our lives a little easier than using long division, but it's very specific. Okay? So synthetic division simplifies the long division process when you're dividing by a linear expression, something like x minus a. Okay, so a linear binomial. You have to be dividing by something to the first power plus or minus a constant, because that's the only time this is going to work. All right, so here's how it's a process. Okay, so there's like steps involved. The best way I can do this is by showing you examples, because it's not like step A, step B, step C. So let's take a look at this one. Okay, so the first thing we notice that we're going to do is we're going to take the coefficients of all of the terms in our polynomial. Okay, so keep in mind that's the numbers in front of the variable. Sometimes people refer to them as constants. So we're going to take the numbers in front of the variables plus the constant. Now, if there is a missing variable, if you start with a fourth, there better be a 3, a 2, a 1, and a 0. If it's missing, you got to put a placeholder in there. Okay, otherwise it's not, you're going to get the wrong solution. All right, so I'm going to take all these numbers. 1, negative 14. 51. So I have a cube, I have a squared, I have an x, and I have a constant. And negative 54. Okay. Now, there are different ways to set this up. This is the way I do it. Okay? I'm going to leave some space, draw a line. Okay? All right. And then I'm going to work with the constant term of the linear binomial. That's this guy. Okay? Now, I'm going to change his sign. So instead of being positive 2, it's negative 2. And there's a reason for that. If I was solving, I would make this x equals negative 2. Okay, so we're going to divide by what we would solve by. And one of the other reasons it's going to make your life easier is that you're going to add instead of subtract. And it just makes it easier for us. So I'm going to come over here, I'm going to take that negative 2, and I'm going to put it on what is called a shelf. Now again, that's the way I draw it. This is the way I set it up. It makes the most sense to me, but there are other ways to do it. Okay, the way to set it up. Process is still the same. They may look differently. Okay, so you have the negative 2 on the shelf. That comes from the linear binomial. You have the coefficients of the polynomial in a line, almost like they were sitting on a line on a lined paper. Okay, step 1. You're going to bring the first coefficient down below the line, and we're just going to kind of like drop it down. So we get a 1. Okay, now, you're going to take the negative 2. You're going to come down here, and you're going to multiply by that number. So we're going to do negative 2 times 1. That's negative 2. And that number is going to go over here underneath the negative 14. And then we're going to add. So negative 14 plus negative 2 is negative 16. And then we're going to do the process again. We're going to take the negative 2. We're going to times it by the negative 16. We're going to get positive 32. That number is going to go under the 51. There you go. And then we're going to add. Okay? So when we add, we get 83. And then we're going to multiply again. All right, so negative 2 times 83 is negative 166. And then we're going to add. Negative 220. Okay, now, these numbers mean something. All right. They are the coefficients of your answers plus the remainder. Okay. Now, why does it work? See, we're going to go back up to the beginning. Okay, I'm going to take this x and this x. Okay, if I take x cubed and divide it by x, you're going to get x squared, right? So that means we're going to end up with 1 lower than what we started. Our answer is going to be starting with x squared. So the 1 is the coefficient of x squared. It's always one lower than what you start with because we're dividing by a linear binomial, or linear something to the first term. So our solution here is 1x squared minus 16x plus 83. And this last number is our remainder. You can write it r negative 220. That's perfectly fine. And that's the process. Okay, you don't have to do with any variables. You're just dealing with numbers. Some of us like long division better, some of us like synthetic. All right, so let's try the next one. Again, first thing I'm going to do is write down all of my coefficients and making sure that if I'm starting with a cube, like it says, there better be a squared, there better be a linear, and there better be a constant. All right, so we have 1 for the x cubed. I don't see a squared, so I have to put a 0 there. I see a negative 57, and then I see a positive 56. I'm going to take the negative 7 in the linear binomial, and I'm going to make it 7, and I'm going to put it on the shelf. Okay, I'm going to leave space and draw my line. We're dropping the 1 down below the line. We're multiplying. Put under 0, add. Multiply. Add. Multiply. Why? Oh, this is negative. Multiply. Add. All right, so that 0 means that there's no remainder. So this is going to be x squared plus 7x minus 8. Now, if there's no remainder, like we talked about with long division, that means that x minus 7 is a factor of x cubed minus 57x plus 56, which means 7 is a root. It's a place where the graph crosses the x-axis. Okay? All right. Let's try another one. All right, so we're going to try and factor completely based on the polynomial function. So we're going to use this synthetic division to factor completely. So let's write our coefficients. Sign in front goes with. We're going to put negative 1 on the shelf, leave a space, drop down the 1, multiply, add, multiply, add, multiply, add. Okay, so that means x plus 1 is a factor, which means x squared plus x minus 6 is also a factor. And what we want to do is take that and factor it if possible. All right, so that's that factor. Are there factors of negative 6 that add up to 1? I believe positive 3 and negative 2. Okay. All right, so our complete factoring is x plus 1, x plus 3, x minus 2. So we now have a way to help us factor something that's to the third power without taking out a GCF. Cool. Problem is that I have to give you one of the factors first. So we're going to work on that. Now, one of the things we find out about synthetic division is called the remainder theorem, and this is really important. This is if you divide a polynomial p of x of degree greater than or equal to 1 by x minus a, your linear binomial, then the remainder is p of a. What exactly does that mean? That means the remainder of synthetic division is the same as if you evaluated the polynomial at the constant that you're dividing by. Watch this. All right, so we're going to find p of 3. So we can do that. We can put 3 in for every x, okay, because that's what evaluate means. So let's do that. So 3 to the 5th minus 2 times 3 cubed minus 3 squared plus 2. Okay, so that's 32. That's 27 times 2. That's 54 minus 9 plus 2. Oh, boy. Can't do that in my head. It's too late. I'm tired. Okay, so 32 minus 54 minus 9 plus 2. All right, I got negative 29. Let's make sure I have the right math there because Lord knows I make lots of mistakes. See, I did make mistakes. Oh, yeah, 327, that's negative 54. Guess I just did bad math somewhere. Oh, no, I did 2 to the 5th is 32. Yeah, that's wrong. Okay, I was wondering why I wasn't getting right. 182. All right, so good thing I checked. Let's do it by synthetic division. We're going to put our coefficients. I have a 5. I don't have a 4. I have a 3. I have a 2. I don't have a 1, and I have the 2. Draw my line. Okay, I'm going to put 3 on the shelf. Notice I didn't change its sign because it's not an x minus a form. I just have the 3, so it stays. Bring down the 1, multiply, add, multiply, okay, add, multiply, add, 82. And lo and behold, that the remainder and the evaluate are the same. That's what happens. Okay. All right. Here's our polynomial. What is p of negative 4? I'm going to do a synthetic division because I find it to be easier. I'm going to put negative 4 on the shelf. I'm going to write my coefficients, making sure they're all there. I don't have a squared term. So 0, 5, 20. Okay, bring down the 1. Negative 4, that's negative 7. That's 28. 0, 0, 0, 0, 5, negative 20, 0. So what does it, if I put negative 4 in, my answer is 0. What does that mean? That means there's no remainder, which means that negative 4 is a 0 of the graph, which means that if I put this in the calculator and see where it crosses the x-axis, you're going to get negative 4. Okay, so it's pretty cool. And if I evaluate, it's the same thing. Okay, so what is p of negative 4? P of negative 4 is equal to 0. What does it mean? It means that this is a root / 0 or a solution to the polynomial. Okay, and if you really want to get crazy, you could say that x plus 4 is a factor. That's kind of deep. All right. Let me know if you have any questions, guys. Please stay safe out there, and I'll talk to you again real soon.